just to make a little more sense out of these calculations, here's a strap. I think it's maybe somewhat less than 80 grams, but it's close enough that we can use it as a demonstration. Now, if I've got it in my hand here and rotate it, okay, give it a good rotation. Okay, what kind of angular acceleration do I get out of that? Well, how long does it take to go from here to here? It didn't take long at all. I think a quarter of a second or less. So in a quarter of a second, if I can go from here to here in a quarter of a second, well, how many radians is that from here to here? How many radians? Well, that's half of a revolution. That's pi radians. And if you don't understand that, you really need to stop and work on the concept of a radian and get that into your intuition a little better. Okay, so anyhow, that's pi radians. That's about 3 radians, ballpark 3 radians in a quarter of a second. So what was my average angular velocity between here and here? Well, the average angular velocity would be the 3 radians divided by the quarter second, 12 radians per second. What would our final angular velocity be? Now, start at rest, I come around to here, I've got quite a bit of angular velocity. Well, if the average is 12 radians per second, then the final would be 24 radians per second. Okay, 24 radians per second. In a quarter of a second, if we divide the change in angular velocity, we're going from 0 now to 24 radians per second. Okay, if we divide that by a quarter of a second, we get 96 radians per second squared. Now, if this is a little less than a quarter second, if it's a fifth of a second, you get up pretty close to the 167 radians per second squared. So that would be a pretty good acceleration. Now, would you get that acceleration from a 2 Newton force exerted 5 centimeters from the axis of rotation? Well, I know what it felt like to do this. You know, pretty good force on my fingers. I'm not going to break my fingers, but if I did it all day, it would probably damage them. I can get that same torque, okay? I can put a 2 Newton force at 5 centimeters from the axis. 5 centimeters from the axis is about here. It's 200 kilogram weight. I put this here and see what that feels like. How much stress is that putting on my finger joints compared to the stress it takes to do this? Well, it feels pretty comparable. So I'm thinking, if anything, this force is a little greater than the force I had to exert to do this. So it makes all these numbers quite plausible.